Hello everyone, welcome you all to AIK Pathshala. So today is the 13th session and today we are going to discuss median absolute deviation and interquartile range. So since we have already understood percentiles and quantiles, let's understand the concept called median absolute deviation. This thing, median absolute deviation. So this median absolute deviation has the same notion as the standard deviation, which we already have discussed. So what is my absolute standard deviation, if you remember? So my standard deviation is something like this. So standard deviation is basically square root of the average. So let's say this is the square root and square root of the average. So this is, let's say, 1 by n summation of I is equal to 1 till n. So this whole thing is my average. This whole thing is my average. So it is the average distance of, let me write here, xi minus mu whole square. Fine. So basically, this whole thing is my average, and it is the average distance of each of your points from the mean value. Here, mu is my mean value. So what you are doing here is, for each point xi, you are taking how far away it is from the mean, and you are squaring it. Because you want to treat points which lie on either side of the mean. Because let's say this is, if this is my mu, if let's say this is my mu, and let's say this is my x1 and this is my x2. So this mu is my mean. So this distance xi minus mu is my this distance, and x2 minus mu is this distance. So one is coming to be positive and one will come to be negative. So I'm taking the distance on both sides. That's why I'm squaring it, and after that, and later, I'm square rooting it. Fine. Now, what it's telling me is, what is the typical deviation of each points from the mean value? What is the typical deviation of each points from the mean value? So let's understand on a similar load, let's understand what is median absolute deviation. So let's understand what is median absolute deviation. Fine. So let's say given a bunch of numbers, let's say this is some number. Let's assume this is my median. Let's assume this point to be my median value. I'm taking this point as median. Earlier, I was taking this point as mean in case of standard deviation. Now I'm taking this point as my median. Now, let's assume this is my x1. Let's assume this is my, let's say, x2, so and so forth. There may be a lot of observation. I'm taking only 2 observation here. So what I'm going to take the distance between these two, the median and the points. So distance between these two is nothing but xi minus median. So distance between these two is basically xi minus median. This is the distance between, and the distance between the points xi and the median is nothing but this is a deviation. So this distance is basically my deviation. I'm calculating the deviation of each one of the points from the median. And I'm taking the absolute value. So let's take the absolute value. This is the symbol of absolute value. Absolute value. Because x1 is on one side of the median and x2 is on the other side of the median. So this value will come out to be positive and this value will come out to be negative in my case. So if I just take median, I will get this positive value. If I get this x1, I will get this positive value. If I get this only, I will get this negative value. So to avoid that problem of negative value, I am going to take an absolute value. So this is my absolute value. So this is nothing but when I apply my absolute value function here, what I am getting the absolute deviation. So this part, earlier this part is my deviation and this whole part is giving me absolute deviation. Absolute deviation. Fine. So I'm basically saying that take the median value for each one of the points. So if I take I is equal to here 1 till n, I will get the absolute deviation of each one of the points from I is equal to 1 till n. So absolute deviation of the points from the median. Because both positive and negative values are there. And what I care about is the distance. So how far is these points from the median? I don't care about the sign. Right after taking all of them, I'm saying compute the median of that. And now you might ask, why are we computing median here? Why not I'm computing mean? This is basically my median. Median. So why I'm taking median here? Why not I'm taking mean? I could have also computed mean here, but I know if one point is very far away, my mean can get corrupted very easily. So median absolute deviation intuitively is doing exactly what your median absolute deviation is intuitively doing exactly what your standard deviation was doing. Fine. So it's measuring how far away are my points from the central tendency, which is median in this case. Earlier in standard deviation, my central tendency was mean, but here in this case, my central tendency is median. So it's very easy. Now let's write a code to calculate the median absolute deviation. To write a code, what I'm going to do, let's copy this entire code from here, paste it here to make my work easy. I'm doing this. Change this quartile to median absolute deviation. Let's write median absolute deviation. Then here let's change, I don't require these things, so let's erase these things. Let's delete this, let's delete this, let's delete this. And here one more thing I want to add. Let me first add it from stats model import robust ROBUST. Fine. Is it? I will explain you why I have done this. Thereafter, let's do one thing. This from here, let's remove this np dot percentile. In its place, let's write robust ROBUST dot mad. And let's just copy this robust dot mad and paste it here also. Fine, paste it here also. Now my code is ready. Let's first run this code. Fine. So I am getting median absolute deviation. If on some of your system, if this stats module is not working, so what you can do, you can write pip install stats model. STATSMODELS. If I run this, I will get requirement already satisfied. But if some of you, because I have already installed it, if some of you have not installed it, you first do pip install the stats model, then you should run this code. It will work fine. Now, to compute the median absolute deviation, since this function is not readily available in NumPy, that's why what we do here is we are using a toolbox called stats models, from which we can import this robust. So robust has this function called MAD. So if I just say robust.mad and give it a vector of values, in which in my case id is setosa, let's say, and petal length I'm passing, it will give me the median absolute deviation. So this is my median absolute deviation. Same way, id is versicolor and virginica. I'm getting the median absolute deviation. So just to summarize it, median absolute deviation is the equivalent of mean, except that median doesn't have the problem of the extreme points or outliers. And median absolute deviation is basically one idea. This thing is basically median absolute deviation is basically an idea which we have developed, which is equivalent to my standard deviation. Why I have developed this idea? Because I want to take care of my extreme points or outlier points. Because in case in standard deviation, this standard deviation get also corrupted by a small number of outliers or extreme points. That's why I have used the similar idea to calculate the median absolute deviation, which is free from my outlier. So there is one more related idea, which is called IQR. What does IQR is? IQR stands for Interquartile Range. Interquartile, QUARTILE, quartile range. So this is my IQR. Let's understand what this IQR. So we will see why IQR is useful little later when we start plotting some of this. So let's go back to this thing, which we have calculated, the percentile, which I have calculated earlier. Say this thing, this is my percentile. Fine. This is my percentile. So what we have studied here, this is my 25th percentile, if you remember. This is my 50th percentile. And this is my 75th percentile, which we have calculated earlier. 25th, 50th, and 70th percentile. So, if you subtract the 25th percentile value from the 75th percentile value, that is, if I subtract this from this 75th percentile value, if I subtract my 25th percentile value, what you get is IQR, interquartile range. So here interquartile range is roughly around, if you subtract like 1.575 minus 1.4, 1.575 minus 1.4, I will get roughly around 0.175. So this is my interquartile range, which means that in this short interval, 50% of your, in this short interval, 50% of your data lies. That's what it means by an interquartile range, right? So it's interquartile because I'm taking the third quartile. This is my third quartile and this is my first quartile. So I'm subtracting my third quartile, first quartile from my third quartile. And I'm saying how many points? So in this range of between third quartile and first quartile, my 50% of points lies. Because 25% points are below the 25th percentile. Fine. And 75% of values are below the 75th percentile value. So we will see how to use the interquartile range. Some people use interquartile range as a proxy or as an approximation for standard deviation, but that may not be the right approximation. But this MAD, mean absolute deviation, is a better matrix to use because we just saw it geometrically that it's very similar to your standard deviation, except that your MAD also doesn't have the same problem of outliers. It doesn't get corrupted by outliers. Fine. Covered. So let's meet in the next session. Till now, keep learning, keep smiling. Take care. Bye bye.